Okay, so it's 12 o'clock. We still have people joining the session a little bit. Um, so I am interested in waiting a little bit, but I'd like to remind you that I have a medical appointment that I need to leave to probably around 1:30. So I won't be around for the whole practical. Um, I'm very sorry for that. I have no opportunity to reschedule the medical appointment, and hopefully it'll go fine, and I won't have to have any additional. Um, so this should be the only time I'm cutting short a lab this term. Um, but yeah, so what we're doing today is we'll be covering the answer key for the first chunk's assignment, and then I suggest that you either continue on the workbook or do the reading in the remainder of the session, possibly even doing the assignment that is due in the next chunk. Because the first parts of that only deal with linear models and further group bys and summarizes about conditional expectations. So yeah, everybody got the assignment in according to my information, which is great, and I'd really like to congratulate everybody for doing that. I guess I had a lot of kind of last minute concerns about knitting and the interpretation of questions and et cetera, et cetera. And I'm usually pretty good at answering email, but I will not be as responsive or forthcoming in future assignments unless there's a very specific issue with the wording of questions. So I really strongly encourage you to ask questions in the practicals. I wouldn't schedule all this time if that wasn't the case. I'm trying to make sure that I get through the discussion board posts about once or twice a week. But just like the best way for you to get those kinds of questions and concerns answered is read the entire assignment, and then if anything seems unclear to you about what needs to be done, ask that question immediately. So read the whole assignment, even if you don't understand a particular technique or approach, and then if there's something you don't, something that seems unclear in the directions, raise that. So I always recommend that you read the entire assignment before you start it. So yeah, but everybody did great. Everybody got something in. So I am thankful to everybody that does that, because that makes this part very easy. So we're going to go over the answers at this point. So let me share my screen. When do you find out your mark? The assessments are due back on, I think, the 5th of November. So you should know about by then. I think that might imply like a single chunk lag. So you'll do this next assignment without getting individualized marks, I think. But the intent is that by doing the answers together as a whole class, you can see that you can kind of get a sense of what your mark might be when you get it back. So it should be about 2 or 3 weeks. Cool. Any other questions on marking or returning or scheduling like that? I'd like to get going just in case we run out of time, because I want to get through all of the answers. But any further questions? How many marks for each question? Kate, there's no specific breakdown of that. The session is already recorded, Emma. It will be posted as soon as I can. It's like recording right now. Any other questions? I'm happy to answer. Going once? Going twice? Okay. So this is public on my website. So if you change the word assignment to answer key, you should be able to see it. What I'm going to walk you through today is just the code for the answer key. And we'll talk a little bit about the answer. I've added some narrative online, but the main point would be the actual code in the answer key. So first off, the first question is, the following data set of temperature from the Filton weather station has a different tidiness problem. And by this, I mean different to the language that I'm using earlier in the assignment. So what is the problem that the yearly temperature has? So first we'll read it. Is it not? Oh, yes. So let's, sorry, hold on, let me set my working directory. Okay. Okay, so this data has in each row a value for the year, a particular type of statistic, and then a degrees Celsius column. The issue in this data frame is that each row contains a variable kind of measurement. The stat column is a variable, it describes the measurement that is being taken, but the individual entries in the degrees Celsius column are of a heterogeneous type. So this row is the maximum temperature in degrees Celsius. This one is the median temperature in degrees Celsius, and this one is the minimum temperature in degrees Celsius. So the variable degrees Celsius has observations that are heterogeneously typed. Does that make sense? It mixes different types of measurements into a single column. This is an example of a data set that is too long. Now, I think in the answer key, I provide you with a way to pivot this into tidiness, but that's okay. I can do that for you now. If we have the temperature data like this, and pivot it wider, we want to get the names from the stat field and the values from the degrees Celsius field, and that becomes a tidy data frame. The reason why it becomes a tidy data frame is because each column is a variable, and each value represents a measurement of that variable. The long form is not tidy because the degrees Celsius variable has different kinds of measurements in it. Does that make sense to everybody? Does anybody have a question about this first part? Seeing none, I'm going to move on. The next part is I see that we have tidied the data. So that is this pivot that I've just shown you. We're getting the, you could say in the answer key, you can use the ID calls to explicitly say that my year is what each row represents. So every row is going to measure a year, and every column then is going to measure something about the year. But because year is the only other column aside from the stat and degrees Celsius, it's treated as the ID anyway. So it's okay to have the ID calls or not in this particular example. Now, if I have pivoted the data to be wider like this, I can compute the range of temperatures pretty quickly as a mutate operation. If I mutate the to add a column called range, I can set that equal to the maximum temperature minus the minimum temperature. And then my range is output. So that's 1.1 and 1.2. Okay. I provide a discussion about how you might actually do this from the untidy version. So if you have temps, I can get the maximums as filter stat is equal to maximum. So now I've got all my maximum. And I might say max temps is equal to that. And I might then say my min temps is equal to temps filter stat is equal to minima. Then I've got max temps and min. If I merge them by year, I get them in the same data frame. So now I've got one row of the data frame having maximum temperature and minimum temperature in the same row. Then I can do the mutate. I will get that. I can do the mutate operation by doing the maximum minus the minimum. But it would be what, degrees Celsius X, degrees Celsius Y. So in theory, there are multiple ways of getting this. And now, what I want to understand is that doing this process of the filter, select, rename, or filter, join, and then get it back into the computation that you need is less, demonstrates kind of a less mastery of the course content than just knowing the right tool to use, which is pivot wider. Conceptually, the operation to go from something that's too long to something that's now wider is pivot wider. So even if you get the range, you may not get sort of full credit demonstrating mastery if you do it in a way that's like the filter operation. Is 1.1 the same as saying that in the untidy data, not all observations form a row? No, it's not. So when he's talking about all observations forming a row, he's referring to the fact that you have, well, I mean, okay, if you conceptualize it in the sense that one observation is a year, and then every single row contains multiple things over here, yeah, sure. So if mapping is backwards, as you're saying, if you're talking about the conceptual observation being a year, and that not all observations form a row, that in fact observations are split over rows, that's fine. But you'll need to explain that that's your interpretation of that individual tidiness point. Because if what you're saying is that conceptually one observation is a year with 3 different variables, then the way you explain that not all observations form a row. However, the way that you can also talk about that is there is different kinds of measurements in variable. So the not all observations form a row is related to this other problem. And if you explain that you think of observation as being one measurement a year with 3 things that we measure, that's fine. But you would need to make that clear in the justification for the discussion. Does that make sense? You need to be able to identify what the observation is and the answer. Okay, yeah, what I was saying was that if you do the filter method rather than the pivot wider, that's okay. You get the right answer. Cool. So I'm not going to penalize you too harshly on that. However, it doesn't demonstrate a mastery of the right answer per se. It demonstrates that you can get through it and you can get to the target, but it doesn't mean that you've understood the concepts that are involved in this pivot. Okay? Moving to 1.3. The week data, let's get that in. So the Weka data very obviously has a problem where it's too wide. Each of these columns has information like a variable that's stored within the variable. So this is the price in the June quarter of 18. This is a variable quarter. This is a variable year. You're going to need to be able to explain how this 2 data set mixes variables into column names. So a distinct variable, quarter, has been turned into a column. There's no variable that records the quarter or the year of a measurement. Sophie, do you have to explicitly say the data is too wide or too long to the mark? I mean, if your explanation is clear, fine. So again, I think you guys expect this to be like really where there's like a checklist of all the things that you have to do in order to get like a pass. So I'm assessing, like, if your explanation is clear, correct, and hits the kind of relevant steps from the tidy discussion, that's fine. Saying the data is too wide, you need to be able to specify why it's too wide. So like later on, we actually use the data in this format because every single row represents distinct geometry. So it's only too wide for a particular kind of measurement. It's tidy if you think about it in terms of observations of individual LSOAs. However, in order for that to happen, you have to mix the quarter and year variables into columns. So these values then become untidy by that definition. So with the data, we can do the pivot longer, where we're going to go from, I think, price deck 1995 to price deck 2018. And you guys pretty much all got this warning, which indicates that you have missing values in your data. That's okay. And some of you might have even fancy and done names too, to rename the columns in one shot. And the best of you might have even figured out that you can drop columns in a pivot by setting their name to NA. This is, I think, in the documentation of the function. So it's not that secret, but it's good to read that documentation when you're learning about the functionality that you're using. So this pivot will be kind of the best pivot that you can do, the cleanest way to transform the data from being too wide into being just what you want. It is not true that multiple variables are in a column, Georgia. So each of this column contains one single measurement of a kind of price. column headers are values, not variable names. That is true. The column header contains a value of the quarter and a value of the year. It is not true that multiple variables are in a column, like was the case in the temps data, where you have a maximum, a median, and a minimum in that. Cool? Right. So we've got week 1. And that's our sort of tidy data frame. Now, I just want to be clear here. This is tidy in terms of the price, but it's now not necessarily tidy in terms of the geometry, right? So the geometry is repeated over and over and over again in the geom column. Every single row has an extra geometry that describes its LSOA. So it's tidy in terms of the price data, but it's duplicated here. It's okay in tidyverse for values to be duplicated in this fashion. But I want you to remember that something being tidy is about its use in terms of variables. So if you want to make a map, and if you say do something like plot belong, right, so st as sf, because the pivot changes it. So if you plot this week along as a map, you're actually going to be plotting polygons over and over and over and over and over. You're going to be plotting multiple different, actually this might actually take a long time. You're plotting multiple copies of your polygons. You're plotting multiple copies of the LSOAs on top of one another. So it isn't actually tidy in terms of a geographical sense, but it is tidy in terms of the price variance. Isabel asks, what does st as sf mean? That's just a way to convert the, yeah, see, I'm trying to draw the, the map. I've told it to stop. St as sf, if you check the help, oh geez, I think I've frozen my R. Yeah, I need to restart. St as sf is a way of converting an object that has a geometry column into an SF object. So I haven't taught that yet. I'm sorry, I'll need to kill this because cool. That start. Okay. Sorry. Okay. Then I think I probably need to not stop recording. I need to re-screen share. Stop. Start. Okay. Sorry about that. Too enthusiastic about showing you stuff. Okay, so we is equal to st read data. We did that. We can tidy library tidyverse. All right, so it's deck 1995 to price. What is it? Deck 2018. So that's our tidy now. Now, I've asked you to, using your new tidy data, use ggplot2 to make a box plot where the horizontal axis is years, the vertical axis is price, and the boxes are colored. by local authority. Okay. So when we use ggplot, we put ggplot the first function, and its first target is always the data that we want to do or use to plot. Then the AES command allows you to specify what's called the aesthetics plot. And it has a lot of different possible variants like X, Y, sometimes it has Z depending on the type of plot. It has color, which you can spell as well. It has group. There's a lot of different things. Fill sometimes. So the AES is a way that you specify how your plot's supposed to look. Okay? So, hold on, switching to something. Okay. So in this particular example, I've asked you to make a box plot where your horizontal axis is years. So that means that X should be equal to year. My vertical axis needs to be the price. So Y is equal to price. I wanted you to color the boxes by the local authority, which means color is equal to LA name. Some of you might also have done group is equal to year. I think only X or group is required in this case. Okay? So this works and is a minimum example. Then ggplot uses this method where you add individual geometries to the plot to give you the plot. And the plot make it look a little nicer. So I do theme axis text X, which is the x-axis text, is a text element at an angle of 45, so that it's rotated. And I'm going to change the justification in vertical space and horizontal space. You don't have to do that. However, I have encouraged you to try and make your plots look nice, and this is one way you can make it look nice. So, this is the box plot that I meant. I wanted to see that your x-axis is the year, your y-axis is the price, and I wanted to see a box plot colored in a different color for each local authority. Okay? If you manage this plot, you'll get some credit. Now, depending on what it looks like and how it's formatted, and if you did that, using the tidy data versus if you did it using some other kind of manipulation of the data, there'll be a difference. But generally speaking, I think, most people will probably get this right. Okay. Now we get to the tough parts. Using tidy verbs such as group by, select, mutate, and merge, can you do a bunch of different things? The first thing I'd like to note is that I'm saying using tidy verbs such as, and then a list. I'm never going to mark you down if you get the right answer and you don't use all the tools that I've told you might use. That's fine. However, you need to be thinking about what's the easiest way of doing this. What's the simplest, kind of most straightforward method to get there? Now, if you made a bunch of intermediate results and you did a lot of filtering and manual manipulation of the data, that's going to get you kind of a less good answer than using the tidy primitives. Now, it is true that you can filter and merge over and over again, get you to do most things that are tidy. But if you can try and use good group bys and summarizes, it's a lot more effective. I also gave you a pretty extreme hint in this example. I told you first and last functions the values of the first group and the last group in a group by. For the challenge problem, that'll be really helpful. So we'll get that in a second. First part, using the tidy verbs group by, select, mutate, and merge, we compute the average price for each year. Okay, so the average price for each year means that we need to summarize all of the observations in all of the quarters for a year. This means that all we have to do is group the data by year, because all of the observations in the year of price are the things we need to get the mean of. So we chunk the data off into individual years, and then we compute the mean price that year. The way that you can reason about this is, if I say a field, like year, then that probably needs to be somewhere in the group by. Okay? So from here, we can use we-get-tidy, and we can group by the year, and then summarize to get the mean price as mean of price. Whoops, that's wrong. There's missing data. So if you have this output, that's about as good as you can get in your answer to this question. The next one, compute the average price in each local authority each year. Okay, so I'm looking for the average for each local authority in each year. That means your target data frame needs to have all of the unique combinations of a local authority and price, or local authority and year. So this automatically tells you I'm asking for 2 levels of a group by. I want your output data frame to have rows that correspond to local authorities in each year. Okay, so to do that, we-get-tidy, we send it to a group by. But now we're going to do group bys on 2 variables. I would suggest that you do this by the year and then the LA name. So what this will do is give us summaries that first start by summarizing the local authorities in each year. Remember that group by stacks up from, this is the kind of large group, and then it's going to split the year into local authorities. Sophie, the LSOA is not the local authority. If you check the data dictionary at the top, the LSOA 11CD is the unique code for the local super output area. It is not the identifier for the local authority. If you do the other way around, you're going to get a summary for the local authority name and then the year. So you're going to get the average value in every year, and then you're going to get that across local authorities. Does that give you the same combination of variables, Finn? Yes, it does. The local authority is going to vary slower than the year in that example. So both of you, I can show you exactly how that'll happen. Could you use LA code? So is LA code unique for every local authority? Yes. LA code is just like a translation into another language of LA name. They're both identifiers for a local authority. I'm using name because I like it more. I think it's a little bit more fluid. If you use LA code, that is 100% okay. However, you needed to recognize that it was the LA and not the LSOA. So we'll do this in this order first, and then we'll do it in the other order that some people did to show you that it's the way that it transforms the results. So group by year and LA name. then I need to summarize to peel off the first group. And by the way, I think I've told you before, but the author of the tidyverse packages, the main sort of proprietor of this universe, he's New Zealander, so he usually allows for all the Anglophone spellings as well as the American spelling. So you can use either one. I'll tend to type Z's because I like having Z's in the language. So in this case, if we use the mean price and get the mean price column and do our na.rm, I get years on the left, I get local authorities in the middle, and then I get mean prices on the right. Okay? So that is the target data frame. The years are changing quickly, the LA names are changing slowly, and then we get the average price in that local authority in that year. Cool. If I flip these, do I get the same result? Well, kind of. Bath and Northeast Somerset is still Bath and Northeast Somerset, and Bath and Northeast Somerset in 1995 is still Bath and Northeast Somerset in 1995. However, the data frames are ordered differently. In this version, the leftmost data frame will change, the leftmost column will change slowly, and then the rightmost column will change quickly. This is another effect of what I was talking about before, where it's going to peel the data frame off and summarize it from the right to the left. By slowly and quickly, I mean that the year column increases in this data frame by 1 in each row. And then it's going to reset when we get to Bristol as an LA name. In the top data frame, the year column doesn't increment for 3 rows because it's going to step through Bath, Bristol, and then South Gloucestershire before it increments to being 1996. That's what I mean by slowly and quickly. In this data frame, the year column changes fast and the LA name changes slowly. In this data frame, the year changes slow and the LA name changes fast. However, it's just an ordering. I can use arrange to get back the form from the top, right? So if I arrange by the year, now I've converted it to be exactly like that data frame. So for those of you that flip the order of LA name and year, that's fine. It's just, it's doing basically exactly what I asked you to do in local authority and then year. But I don't really mind. Either way is fine. I conceptualize it easier to read that being year and then the local authorities. But if you prefer it to be sorted on the LA name, like I said, it's just a sort. Georgia, the issue with the is it better for something to be on the leftmost versus the rightmost? Yeah, there's not quite. I don't really care. So it's not better or worse for it to be anything. Normally in data sets, like it's a convention to have the slowest moving things on the left, and as you go right, things change faster. That's fine. It doesn't matter. It really honestly doesn't matter. It's just a sort. So it's one of these things that's like ephemeral, basically. Now, yes, there is a case where the order of a group by may matter, especially when you're not just computing means, but you're computing more complicated statistics. So if I wanted to summarize this again, right? So let's say I have 2 group bys, and I now want to get the median of that mean price. It's going to summarize from right to left in the group by. So it's going to construct the summary over year. Now, if I've reversed it, I'm going to get the median in years. So that's exactly the context where it matters. If you do the group by, remember that things are going to unpack from right to left. And for every unique combination in the first summarize, it doesn't really matter. Once you start getting to additional summaries or manipulations, it can matter significantly. Further, for constructs like first, whoops. It's going to matter if it's one or the other. Oh, maybe not. Oh yeah, I guess because the first price is always March. Yeah, so there are some constructs where it'll matter in addition to in addition to repeated summaries. But I don't recall exactly what the conditions are when these happen. But again, my main point is that the only time you need to be worried about this is if you're sort of doing additional summaries or any kind of other thing. If you do it in this particular order and you recognize that the data frame is the same in this form as it is in the other form, you're fine. It's just a difference of a sort. Okay? Cool. Isabel asks, for each of our answers, did you need to knit or cable them? So you don't actually have to cable all of your output. You can just put the code, and I can verify that the code is correct myself. The other thing that's important is that, like, I don't care if you cable your stuff or not. You can just output the tables. But think about it like if I gave you something where nothing was shown except for the code, it would be challenging to assess whether or not I understood what I was talking about. When I give you stuff, I have explanation, code, and output. So when you give me stuff, it's best for you to do that as well. And you'll have to do that with employers or etc. Georgia asks, what exactly does cable mean? Well, it's a pun. In knitting, cable is some kind of relevant term about actually the physical process of knitting. Practically speaking, what the function cable does is intended, it returns a single table for a single table object and returns a table that contains multiple tables, blah, blah, blah. How it's used is to format tables for knitting in R Markdown. So in the console, if I just say Rika tidy, oh geez, it's going to take a while. It's just used to format tables effectively. I'm so sorry. There we go. So let's say, we're doing this on the head of Rika. It's going to make it look nice, or attempt to make it look nice, right? So you see these little separators that it's giving us to output into the table, and compare that to something like this, where it doesn't really have the nice separators. People may disagree about what looks nicer. This is a format that looks good in Markdown, in an R Markdown report specifically. And when I use it in the R Markdown, it's outputting that table so that it gets turned into nice, like nice HTML when you read it on the web. Cool. So you don't have to use it. No expectation to use that. Like many functions, though, just so that you know, I can stick it at the end of a pipe. So like, oh, whoops. Let's just do temps. Oh. Anyway. You can stick it at the end of a pipe. So you don't actually have to wrap everything in the knitter function like I do. I just do it that way because I like the way it looks. but you can put it at the end of a pipe and it works fine as well. So that is how you do 2.3 median price for each local authority, or average price in each local authority in each year. The next question is the median price for each LSOA since 2008. Okay, so I didn't ask you for each LSOA in each year. I got some email questions asking for that clarification, saying, oh my God, I did one thing or I did another thing. Read the question and answer the question. I can't I can't field all the email that asks me the things that I didn't ask. So it's okay if you need clarification, read it all over before you answer, and then ask questions in the lab. I love making sure that I'm clear. So please do that in the future. The question says, compute the median price for each LSOA since 2008. So that means that in an LSOA, we have some example of a median price over time. So we have the Weka Tidy data. Oops, not that one, yeah, that one. Weka Tidy, and then we have to filter. We want years since 2008. Now, if you did years after 2008, I'm not going to fail you. It's not a trick question. I don't care about whether or not you conceptualize since as being inclusive or exclusive of the endpoint. However, what that means to me is greater than or equal to. So it's okay. So we do that filter, and now we've got years since 2008. Sorry, Sophie. Yeah, I'm using a font that swaps the symbols if they're like it turns arrows into arrows and kind of different things like that. I use that because I like to read that. But yes, that is the same thing as that symbol you've just put in the chat. So we do the filter. Now I want the median price for each LSOA. Each is an example that the rows of the output data frame have to have LSOAs changing. So we need a row for each LSOA. So we group by LSOA. Now you can do code, you can do name, or you can do 11 CD. They're all unique for the LSOA. I'm going to do name, and the answer key, I think I might do code. It's fine. Then our trusty summarize, and we want to get the median price in the LSOA. So the output data frame has each LSOA and its median price in the years since 2008. Cool? Now, if you got to that point, you could just stop and be totally done. The challenge question, Sophie asks, will we be penalized if we grouped by year and LSOA 11 CD? Okay, so I'll tackle it in the order they came in the chat, guys. So Sophie asks, will we be penalized if we group by year and LSOA CD? Does that look the same as what I've asked for? No, it doesn't. So that's giving me the median price in each year in each LSOA. That's not what the question asks for. So I see that you can demonstrate the understanding of doing the code, but the connection between what's asked and what you've done is not there. So like this will get partial credit for sure, but it's not what I asked for. So I'm sorry, but I don't know how to ask that any clearer. The median price for each LSOA since 2008. Noah asks, is it good practice to remove missing values when computing the median? Does it change the result? Sometimes. I don't think at this point there's missing data. If you remove, I think R treats NAs as, actually, I'm not actually sure how the median counts NAs. Huh. Yeah, so in general, I would remove the remove NAs. But yeah, I'm not actually sure how they're considered. In other kind of contexts, NAs might represent like infinities, and you do want to count those in the median. So I think it depends on the context, and I'm not exactly sure how R represents NAs in the median computation. Anyway, I don't think there's a median NAs in the data since 2008. The NAs all occur in like 1995 through 1998. Emily Blackman, she asks, does it matter if you do a filter after the group by? Let's investigate. So if we do the LSOA name and we remove the filter, okay. So obviously if you don't filter at all, that's wrong. If I group by and then filter where year is greater than or equal to 2008, and then summarize, okay, is that any different from doing it the other way around? No. The filter can happen at any stage of the process before the summary. Okay? The summary is what we call a destructive operation or a reduction. So all of your manipulations about what data gets reduced has to happen before the summary. But grouping something by a variable and then filtering the groups you're going to consider is exactly the same as filtering the data you're going to group and then grouping the remaining things. They do the same thing. Good question. Isabel asks, do we need to give columns a name or just keep them as median price? I don't care. Whatever you did is fine. If you go on to need to do operations on this median price, it'll be helpful if you call it something like median, because then it has a real name that I can work with in the data. Like, so say, if I save it as a data frame, then I can access the median price as a column. However, I guess it does propagate in some ways, Noah. So I don't mind if you remove the NAs or not. However, if you just do median price, then you have to access it using the kind of annoying backtick structure, which is median price. That's not very nice. Isabel asks, in our pivot, if we did this, values drop NA equals true, then do we need to do NA.rm further, or will it have already dropped the NA values? It will have already dropped the NA values, so that's fine. I didn't ask you to drop the NA values before. In general, it's a good idea to not drop NA values when you're doing the pivots, because you want as much as possible for your transformations of data to be interchangeable. So you want the same information represented in wide or long or moderately wide or whatever. Thanks, Georgia. I can edit the question for that, but I mean, everybody has a different interpretation of these things. So, I edit some of these questions every year, and there are always people that bump into it, I think because they're thinking too closely to the last question to read this question, but that's fine. I can incorporate that change if folks find it clear. Happy to do that. So yeah, I said, it's fine if you drop the NA values, it's okay, but it's sort of in general, maybe don't do that, but I'm not going to mark you down if you do. And then yeah, I can incorporate that revision to the wording, and that's super okay. Thank you for the suggestion. Okay, so now we're on the challenge question. So, make a map of the percentage change in prices for each LSOA since 2008. Okay, so you know that it needs to end up in a map. So we need to somehow get back to data that has rows where there's an LSOA, and then I need to have a column that has the data that I'm asking you to compute. So I'm asking for the percentage change in prices for each LSOA since 2008. And again, I don't really care about if it's inclusive or exclusive of 2008. So the way that I answered this question was this. Weka tidy. I filtered by the year. Now, I'm going to group by the LSOA code and year, because we have 4 measurements in each year. Then I'm going to summarize the price as the mean price in a year. So I'm going to compare the average price in 2008 to the average price in 2018 for my percentage change. It's okay if you picked identical points in time. So if you compared the March quarter in 2008 to the March quarter in 2018, I'm cool with that. That's great. One thing that would be less ideal, but still kind of gets the point across, would be the first observation in 2008 to the last observation in 2018. It's not the best, but it's not the worst. Okay? So first, we're going to do this. And we're going to get a unique value of the price for the year for the LSOAs. Now, it just so happens that the years are already arranged in ascending order. But in the answer key, I explicitly do that, because I'm going to use the functions that I told you about in the hint, the last and the first function. So I've stacked up the years, LSOA codes, and the years, right? And if I summarize this again, say last price, let's do first price because it'll be easier to see. The first price is the price in 2008, because it's the first value that occurs in the year groups. Does everybody see that? So the percentage change equation is the last value minus the first value divided by the first value. And if you wanted to multiply it by 100 to give you a easier to understand rate, I'm cool with that. Those are the price changes. So if you save that as percentage change, our output is that. Zoe asks, is it okay to filter by year rather than using the first last function? Yes, that's fine. But what that is, it's a kind of a less, if the best way to do it is using first and last, then the next step is to do it by explicitly specifying the years you're comparing. That's okay. It doesn't use the revealed information in the hint. It uses what you know. That's fine. So I'm okay with that. So once you get this data frame, I might call this, I don't know, price changes. So as long as you've done something like this, where you've taken a value in 2008 or 2009, either itself a summary or maybe a corresponding value in each month or something like that. As long as you do that and you get 2008 compared to 2018, that is the best way to go. Now, some of you might have done this. Price 2008 is equal to week of tidy, filter year is equal to 2008, and then price 2018 is equal to week of tidy, filter year is equal to 2018, and then done operations on those two data frames. That's less than ideal. The reason why is because you have no guarantee that those two data frames have the same number of rows. If they have missing data, you don't know it's been dropped at some point. The filter, remember, drops different aspects of missing data. And you have no guarantee that the order of rows in those two data frames is going to be what's called conformal. So if I have price 2008 and price 2018, if I have missing data at some point, then row 4 of this data frame is not going to correspond to row 4 of this data frame. Now, I might be able to merge those two things back together, but doing this as a kind of a separate thing where you're not doing the operation inside of like a pipe is not as good as the solution I've just shown. So you'll get the right answer if you do it something like this, but it's not the intended way using the tools that I've shown. You want to try and make it so that the operation that you construct is just self-contained. That's the whole point of the pipe, is that once you get an intermediate result, you can send it somewhere else. Another example that I saw in applied cases was something like week of tidy. You filter, let's say year is equal to 2008 and year is equal to 2018, and then pivot wider, where you say first is equal to, or you say names from is equal to year, values from is equal to price. And then they do computations on those two columns. That's totally cool. That displays a very sophisticated understanding of what you're looking for from the percentage change. I'm fine with that. This recognizes that our previous solution, storing the two values into their own separate data frames, can be done directly with a pivot. As I told you earlier in the answer session, anytime you're making a bunch of data frames that correspond to a filter and then sticking them back together, that's essentially a kind of pivot. If you recognize that what you need is a filter and then a pivot, you're doing a great job. Alternatively, if you recognize that you can do that pivot implicitly from using first and last, that's okay too. Anything else that does kind of intermediate results storing and comparing data frames that you're assuming are aligned based on their ordinal relationship, that's not as good of a solution. It'll still get credit, but it's not as good because it's not recognizing the conceptual structure of the problem. Does that make sense to everybody? Okay. So once you get the price changes, then all you have to do is merge that back into your original Weka data. So here, I might do something like Weka, and in the assignment, I actually didn't use a tidy tool to select the columns I wanted. I went like this, and then did price changes by is equal to LSOA code. So I actually am guilty of not using the tidy thing here, so I wouldn't give myself full credit. What actually is technically the tidy thing to do would be something like this, where you say select LSOA code and geom. I don't mind, that either way, they do the same thing. I would not give myself, absolute full 20 points on the 20-point scale credit for using the selection operation like I did. okay? But once you have this data, you've merged your percentage changes back into your geometries, and now it's a plot. And that is the result. So you could say, save the output of the merge as price changes again, and say price changes PCT change. All told, that is a single group by or a single pivot, a merge, and a plot. So 3 conceptual steps. A group by, a pivot or a summarize, depending on how you do it, a merge, and then the plot. Zoe asks, could we have used inner join? Oh yeah, you can. You totally can. That's the tidy collection of joins. Super cool if you use that. Absolutely great if you use that. Sophie asks, is it okay if you use tmap? Yep, I don't care how you make the map. I never specify to use the plot function. However you want to make it pretty, that's cool with me. The point is pretty code. Do you get credit added if you make a map more stylistic? I mean, it's not like a linear trade-off, right? Because you can make a really pretty map of incorrect information, and then I'm not going to give you full credit. So it's not a linear trade-off there. But I do appreciate it when you make things look nice and you explain what you're doing. So I love it. North base maps, great, fine, do it. I love it. But it doesn't, if you do the kind of temporary assignment things or you get the wrong information, it's not going to salvage that kind of conceptual error. Noah asks, was it okay if we started back from the original Weka data instead of pivoting from the tidy version? Interesting. So the one way you could have done that, I suppose, would be to select the columns you were interested in and then computing the percentage change from there. That would be an interesting way to do this because you, Isabel, sorry, before I proceed, price changes is the data frame now that I've merged back onto the geometries. You can check the answer key for that online as well. Yeah, no, I can't really give you anything more specific than that because if you are working with that, then you're going to be doing selection operations on specific, what are called like magic values, right? Like the identical, you're going to be pulling out individual columns by name or by value and then comparing them. So it is good that you recognize that the data frame is already wide, which is the format you need to map. But it's also, again, it's not using explicitly the tools that were taught in this point. So I don't know, it'll depend, I think. If you pull the columns out and then do the means manually, it's not going to be right. So cool. So that's it. That was the assignment, was a bunch of group bys, a bunch of summarizes. So from what I heard from most people, it seemed like it was okay. I think that y'all are a little nervous about it, and I think that's fine. But I encourage you again, last year, most people passed with a really nice grade. The course is designed to support you, even if you get 1 or 2 bad assessments. So it's okay if this one feels like it was really kind of off the mark. But don't worry, you're probably not going to be penalized too badly for anything. Does anybody have any other questions about the answer keys or ways that I have suggested that you answer these questions? Again, you can access it yourself by ljwolf.org/teaching/GDS00 answer key.html. I'll make sure that it gets posted in the Blackboard as well. So, cool. from this point, I will make sure that the assessments are graded as quickly as I can and that they're returned to you with individual feedback. My hope is that by doing this kind of thing where you do the submission the day before and then we go over the answers immediately, will give you kind of enough time and appropriate anxiety reduction to be okay with maybe getting a few things wrong and fixing them for the next assessment. So I hope that this is sufficient. If you have any individual questions that you'd like to talk about, definitely schedule what are they called? Office hours with me for the coming Monday. I'm more than happy to talk about things or help you kind of with a further explanation or additional talk about the way that these questions are answered. But yeah, I think it's pretty straightforward. I appreciate the suggestions on how to improve it. I really value your feedback on sort of things that you find confusing. So let me know if there were sort of interpretation issues. As I've said, year after year, no matter what you do, there's always going to be people that misunderstand something that's asked like that, and that's okay. But we want to minimize that. So do let me know. For the rest of the day today, I would recommend that you work on the workbook for chunk 1. You work on the assignment for chunk 1, or you do the reading for chunk 1. Okay? Any other questions? Going once. Going twice.